All right, thanks everybody. So appreciate all of you all coming out today. There's a lot of good talks going on right now, and appreciate you all coming in. So today we are going to be talking about NoSQL. So let me just see a show of hands. How many of you have worked with a NoSQL solution before? Okay, so it looks like about half the room now. NoSQL encompasses a lot of different types of databases. Pretty much anything that doesn't use SQL as a query language could classify itself as a NoSQL solution. And so today we're going to look at traditional attack vectors against relational databases, how those attack vectors transfer into the NoSQL world, and then what we can do about it. So first, why should we look at NoSQL security? NoSQL is really, really popular. The NoSQL solutions that are available right now are scalable. They offer a lot of great features like sharding and redundancy if you have large deployments. They're extremely flexible and easy to use. So you can spin up a NoSQL deployment on a laptop very easily and start hacking away on a new project without having to set up a lot of infrastructure. And they're also pretty cost efficient because most of these applications are free. They're open source projects, so you have the ability to add features and use them without having to do a lot of work. But you'll find that when it comes time to actually scale these solutions, the cost factor does not always scale with that as well. So the trust model for these specific databases is very different than a relational database. And so we need to take that into account when it comes time to scale your application off of your laptop or your desktop and into your corporate environment. And so to give you an idea about why I originally started looking at NoSQL security, it wasn't because of any of these specific reasons right here, but it was because of comments like this. So Redis is designed to be accessed by trusted clients inside a trusted environment. So who all is confident in saying that their entire data center or their web infrastructure is a trusted environment? Any? Okay, I don't see any hands. Let's look at Mongodb. The trusted environment is the default option and is recommended. And it's often valid to run in a trusted environment with no in-database security or authentication. Or my favorite, which is Couchdb. Couchdb allows any request to be made by anyone, and it should be obvious that putting a default installation on the internet is adventurous. So I don't know about you all, but when I hear the word adventurous, I'm thinking of something like this, jumping out of a balloon 24 miles above the Earth's surface, instead of simply connecting your laptop to your local area network. So this is the NoSQL predicament. A lot of these solutions are great. They're great at solving big problems and handling big data. They're used in security architectures a lot for storing logs and handling IDS data, but are we still comfortable doing that knowing that these databases can't stand on their own? So before we get into any specific NoSQL issues, let's talk about relational databases. So I'm sure many of you recognize the vendors that are shown on this screen. A lot of these databases have a lot in common. In terms of feature parity, they're more or less storing data the same way on the disk. They're all using SQL as the primary query language. And they also have some integrated security features that are found throughout the entire group of databases. So for instance, they all have the ability to authorize clients to make specific actions within the database. They all have the ability to authenticate a client when the client connects. And for the most part, they all have some technology built in that ensures that when you're communicating with that system, your data is being kept confidential. Some of them even have integrated support for encryption or cryptographic functions like being able to calculate an MD5 or a SHA. So these are all things that we've become accustomed to. A database developer might not need to worry about using a hash function in the application if he can integrate that functionality into a trigger or some other sort of functionality that's integrated in the database. Now, in terms of attack vectors, y'all will recognize a lot of these. This is pretty straightforward. Right at the top, we have injection attacks. SQL injection is number one on the, or not SQL injection, but injection in general is number one on the OWASP top 10. We've got issues with privilege escalation and credential brute forcing, which affect a variety of different environments. we've got authorization weaknesses, and then generic software vulnerabilities. So if we have all these issues with relational databases, and when we've been using these solutions for years now, what does this mean when we move to a NoSQL environment? So today specifically, we're going to be focusing on these topics: injection, authentication, authorization, and confidentiality, and how they're being implemented in the NoSQL world. So first topic today is going to be injection. And like I mentioned, injection attacks are #1 on the OWASP top 10, but what makes NoSQL unique is that the types of databases that we're working with are increasing in their diversity. So we don't have one query language anymore. One architecture could be using JSON to query the database. Another one might be using SQL. A lot of databases will let you use JavaScript to query the database. And so if an attacker is trying to get into your application, they're going to have to figure out what language you're using first as a part of your architecture. This also means that when you're trying to secure that application architecture, you need to be aware of specifically how they can exploit these different types of languages. And our injection attack surface is increasing as well. So instead of traditional query injection, like SQL injection, we can now inject schema into a variety of document databases and JavaScript, which is really fun. And so all in all, when you have a NoSQL architecture, the complexity of attacks that you will see against that architecture are much greater than what you would have with a traditional SQL database. So before we talk about document databases in detail, let's talk about collections first. So in the NoSQL world, they have sort of gotten rid of this concept of a table, more or less, which in the SQL world is a well-defined, well-ordered structure. It's easy to sort tables and to query them effectively. So to make an analogy, in the SQL world, a table will be a card catalog. Whereas in the NoSQL world, for the most part, collections can hold whatever you want to put in them. You can have different objects with different properties, different shapes and sizes. And so as an application developer, we need to make sure that we understand what is being inserted into our database and what is to be expected when we're working on these specific types of issues. So schema injection allows us to insert our arbitrary key value pairs directly into our database. And we primarily see this when we're doing something dumb like simply iterating over all the post values to create our documents. Now, this is a very convenient thing to do if you're using a framework that allows you to just iterate over any post items. If you're just building your document straight off that, it's very, very easy for an attacker to insert arbitrary data. Now, I'm sure y'all are saying, but I would never, ever do that. I would encourage you to go Google how to iterate over post in a variety of different languages. There are Python web applications that are doing it. There are Ruby applications, and there are PHP applications. And these are all things that you can find online. Unfortunately, most of them are open source. So these are definitely things that you need to be aware of. In terms of schema injection specifically, there's two different types of overrides that we can do. We can override schema within the JSON object itself. So that is, if your application is going to consume the JSON that's being sent by the attacker, any additional JSON that's added after the fact will override what was in there originally. And then we can also do this in the query itself. So if you simply specify an object twice, the last one that's going to get parsed by the database is going to be the one that gets written to the database. So in a perfect example right here, an application-controlled attribute, like setting the admin flag to false, can be injected by the attacker and set to true. And when that's actually written to the database, that will be true as well. Now again, I tested this on a variety of different platforms, and unfortunately, the drivers that I was working with specifically don't do a good job of filtering this out. They don't throw any errors, they just simply take your query as it is and send it to the database. So for those of you who are familiar with HTTP parameter pollution, this is very, very similar. And thankfully, we can take some of the same mitigation ideas that we have for HTTP parameter pollution and apply it to this as well. So in a relational database, schema injection is not an issue because we have strongly typed tables. We don't have to worry about people adding additional columns or additional values because they simply can't. We'll get an error back from our database. But in these NoSQL solutions, we have typically the ability to insert a value that may be used in the future. So for instance, if you know that an outdated version of software is running on the web server, you can insert a value that when the database, or excuse me, when that software is upgraded to the most recent version, will allow you to take advance of some new features that might not be available. So there's a lot of issues that can come with schema injection. Now in terms of mitigating this, the two main things that I identified were key enforcement. So being aware of what should be inserted into each collection and either whitelisting or blacklisting those values. So for instance, if you have an admin flag, make sure that you don't want to see the admin flag coming in via post or in any of the strings that are being passed into your application. And also, if you are using strings, which you shouldn't, make sure that you're replacing or concatenating any of your application managed keys at the end. So in terms of query injection, the good news is that most of the languages that have native JSON objects have implemented them safely, and so this is not a concern. The bad news is that people are idiots, and they are going to continue to use strings, and it is still possible to inject into strings. There's also some language-specific constructs that we can abuse as well. So PHP does a lot of weird things with superglobal values, which we'll talk about in a second, that can be used to your advantage if you're attacking or trying to defend a NoSQL architecture. There's also some issues with the way that strings are converted to JSON. So if you have the ability to inject into, say, an AJAX request into a web application, you might be able to insert some values before it's actually handled by the JSON parser. So PHP superglobals, I'm sure many of you have worked with PHP. They basically allow a web developer to easily create a multi-dimensional array inside the PHP application based on the name of the input values that are being passed into that application. Now, what's great about this is when you need to access those values later, it's very, very convenient if you're working with a lot of data. Now, the specific issue here, though, is that PHP also uses multi-dimensional arrays to represent Mongodb documents. So if you're working with Mongodb, you're going to be creating these same arrays, and you're going to be sending these specific values to the database in order to query it. So we can weaponize superglobals by changing the post values and using it to create MongoDB comparison operators. So instead of simply going in and checking values, we have the ability to actually modify the intent of the query just by changing the name of a post value that we're submitting to a form. Now again, if you're doing key enforcement or some other mitigation mechanism, then this might not be an issue. Obviously, if you're looking for things like nested arrays, you can potentially detect this as well. But if you're implementing MongoDB, this is something that you need to be aware of. Now, this is not an issue with the MongoDB architecture. The driver is simply taking an array and executing it like it should. But if you're inputting a MongoDB application, you need to make sure that you're checking for these types of attacks. And the same does not apply to many other types of databases. So when you're implementing a NoSQL solution, it's very important that you know and are aware of any of the types of attacks that might affect that specific solution. Now, a lot of credit needs to go out to Brian Sullivan. He did several presentations last year on NoSQL security issues, and if you're interested in learning more about this specific issue, he has some great slides. He also did some work on cross-site request forgery and NoSQL solutions that I'm not going to cover today, but if you are interested, I would definitely check out his presentation. And then we have JavaScript. So like I mentioned earlier, a lot of these databases support JavaScript, and what that means is that we potentially have the ability to inject JavaScript as well. Now, JavaScript is built into these languages because they don't have a lot of the functions that we're used to in the SQL world. So instead of being able to count or do aggregation functions, a lot of these specific capabilities are built into the JavaScript stack itself. So a couple specific examples. If you're using MongoDB, there's two different places. You can actually pass JavaScript as a SQL query to the MongoDB application to be able to determine which type of items to return. And then there's also a db.eval function, which if you know an application is using that specific call, allows you to execute those calls as an administrator against the database. So for instance, to create a database, to add a user, or do some other specific types of actions. And then Couchdb has a concept of a temporary view, which is essentially a view that's created on the fly. And so if you're able to inject into that specific type of call, you can potentially add JavaScript to the database. So, server-side JavaScript injection is not a new issue, and there's lots of things like web application firewalls and IPS units that are designed to detect these types of attacks. But you need to be aware that if someone is able to bypass one of those specific types of protections, you could potentially be dealing with an issue in your database. It's not simply a client-facing problem. So again, mitigating all these injection attacks, it's really important that if you have native JSON objects in your language, that you're using them. We need to make sure that we're escaping any of our input, and be careful when you're working with variables that are provided by the user. It's also important that if you are accepting JavaScript, you're sanitizing, and make sure that your defense in depth or your threat model is up to date and is trying to identify these specific types of attacks. So the next topic that we're going to discuss is authentication. And so the specific authentication issues that we're going to look at are weak authentication methods, weak password storage methods, and then opportunities for password brute forcing. Now, relational databases traditionally have rich authentication support, which means that you can easily authenticate against a variety of credential sources, whether that's Active Directory, LDAP, PAM sources, or sources that are actually built into the database itself. And relational databases also do a very good job of hashing their credentials when they're stored offline. So they generally aren't stored in plain text. Now, in NoSQL solutions, this is often not the case. So the security that's enabled by default, especially pertaining to authentication, is limited or just not enabled at all when you first start using the application. And that's designed to support rapid development. So the idea is you spin the solution up on your laptop and you can start using it effectively. The problem is that when it comes time to scale these solutions, a lot of times the authentication solutions cannot scale effectively beyond your specific host. So the two types of authentication methods that we're going to discuss today are RESTful authentication sources and non-RESTful authentication sources. So if you're using a database like Couchdb that does support REST, it's going to be using one of three different types of authentication: HTTP basic, HTTP digest, or cookie-based authentication. Now, what's crazy is many of these databases support these types of authentication, but have no concept whatsoever of any kind of data encryption or support for SSL. So if you're going to be deploying this on any type of device that's going to be available, you may potentially be looking at implementing a reverse proxy server or some sort of load balancer or SSL solution in order to ensure that data that's coming to this device is encrypted. For non-RESTful solutions, ideally we would want these solutions to implement a challenge response protocol, but that's just not the case. In many of these specific solutions, I have the authentication from Redis on the screen right now. There's just no encryption whatsoever. So right there next to the arrow, you see me authenticating. If anyone is actually watching on the wire, they're going to simply capture your credentials. So again, you would think that we would want an authentication method that's resistant to replay attacks, but that's just not the case. And there's also weak password storage methods as well. So in many cases, passwords are simply stored in the clear, whether it's in the database or on your hard disk. And in cases when they're not, the hashing that is being used is less than ideal. So in the specific case of Mongodb, we're still using MD5 to hash passwords. Or in Couchdb, we are using SHA-1, but I think even that leaves something to be desired now. So ideally, we'd also want the password storage to be limited. And so if you're using a relational database like MySQL, a lot of times we'll find that a non-privileged user won't even have the ability to query the admin database that contains all these credentials. But depending on your solution, they may be able to query that. There's also a lot of opportunities for password brute forcing. So Redis in particular is extremely vulnerable to password brute forcing. This bash script I wrote right here just iterates over the rock.u.text password dump, and I was able to check 10,000 passwords against a Redis instance in a little under 30 seconds. Now that was on a virtual machine, but again, if this thing is exposed to the internet, it's just a matter of time until this thing gets owned. So just to review authentication, the authentication schemes that are supported by these solutions vary widely depending on the type of solution that you're working with. If you're using a REST-based solution, you need to make sure that solution supports SSL, and you also need to figure out if it supports authentication at all. And then the native authentication schemes that are built into these solutions are relatively weak. So we've got real issues with replay attacks or man-in-the-middle attacks, not to mention the fact that it's very easy to perform password brute forcing. Now, pluggable authentication is something that's coming. While I was working on the content for this talk, I was in communication with a variety of NoSQL vendors, and many of them had things like Kerberos support to add more enterprise functionality. And so while that may be available in the future, it's not available right now. So authorization. Now, in the SQL world, we had this concept of SQL's DCL, or data control language, which basically integrates the ability to grant and revoke permissions on any specific table built into the language. This is very handy because it provides granular table level access for specific operations within the database. And this is native access control that is built into the architecture itself. So it's not something additional that needs to be included. It's simply built into the language. Unfortunately, we don't really have a corollary for that in the NoSQL world. So we see that authorization, when it's supported, is very architecture dependent. It's generally per database, not per collection. So you can throw out the idea of only restricting specific users to specific tables. That user is going to have read or write privileges to the entire database. And when they do get those privileges, they're generally coarse-grained. So unless you're using validation functions or some other sort of technology built into the solution, you can generally only choose between read and write. And every architecture is different, but there are three common themes that we see. Most NoSQL solutions have a concept of an admin role, which allows you to do things like reboot the database server, create new databases, and add and remove users. There is at least a differentiation between read and write, which creditors do. And then, in general, authorization is not required until it's enabled. So, again, if you're going to be relying on authorization heavily, this is something that you would need to be implementing in your application architecture itself. Now, there are some inventive solutions. Couch has a concept of a validation function, which is basically some JavaScript that's included in the database itself, and allows you to ensure that any of the data that's written into the database goes through this function. So you have the ability to block write requests into the database through the use of a validation function. Validation functions could also potentially be used for something like encryption. So if you want to ensure that a specific column was always encrypted, you could potentially use a validation function for that as well. There is some concept of role-based access control. So the idea of setting up user roles and security groups. Have any of you ever heard of Apache Accumulo? So it is a fork of Hadoop that was released by the National Security Agency a couple years ago. And it has a concept of user roles and security groups where multiple users can actually have different visibility within the same key value pair. So if you're an administrator account, you might be able to see some values, and if you're a reader or a writer account, you can see different values. And the idea is that the document can have selective visibility. And then there's also command renaming, which is probably my favorite authorization solution. And I like to refer to this as authorization through obscurity, which is basically where you have the ability to rename a command within the database. And if the person that's connecting knows that command, they can run it. But if they don't know the name of the command, then it just won't simply execute. So again, depending on the solution that you're using, you could really have a difficult time implementing authorization at all. And then we have confidentiality. So in confidentiality, we're specifically looking at protecting data at rest and in transit. So confidentiality in transit, we're looking for things like key verification or the use of SSL and TLS. And then confidentiality at rest, we're looking for things like supported cryptographic functionality. So the ability to encrypt data natively in the database or to have easy access to hashing functions. So unfortunately, there's basically no support for confidentiality whatsoever. There is some SSL support in Mongodb, but beyond that, you're basically going to be looking at either implementing S-tunnel or some other SSL solution to add that functionality to your database. And a lot of times, if you read the documentation for these databases, they'll tell you to go out and make sure that you're securely implementing a VPN or some other sort of transport layer encryption technology. But it's pretty much up to you to do it correctly. And the issue with that specifically is that a lot of these databases are designed to scale. They're designed to shard and replicate against a variety of different environments. And so they'll help you with the data part, but not necessarily securing any part of that process. And then in terms of support for encryption at rest, there's essentially none. I haven't yet to find a database or a NoSQL solution that supports native encryption within the database solution. Now, there are third-party solutions that you can purchase that are designed to essentially act as proxy servers for your NoSQL database that will allow you to do things like encrypt data that's being written to the database or make sure that it's being sent securely when it's in transit. Now, why would you want to do that? Is anyone in here that has used NoSQL storing credit card data in their NoSQL solution? Okay, good. So like there's a specific part of the PCI DSS that says that your database solution must be able to authenticate and authorize your users, which is not even supported by most of these solutions. So if you want to store credit card data, you would potentially be looking at having to implement an additional third-party device just to be able to support that. So we've talked about some specific issues with different databases. If you are using NoSQL and you do need to deploy these in your enterprise, how are we actually going to secure those deployments? So when we were looking at all those quotes earlier, you all saw trusted operating environment being mentioned over and over again. A lot of times these NoSQL vendors say that because their trust model is that it must be implemented in a trusted operating environment, it's up to you as the implementer to ensure that everything is done securely. So with that being the case, you need to make sure that you understand what your trusted operating environment is. Does that end at your web server, or does it end at the database server itself? And you need to understand how data is getting in and out of your database solution. So identifying those ingress and egress points and make sure that those specific points are secure. Like I mentioned just a minute ago, there's also some real issues with compliance. So if you are storing credit card data or health data or working with student data, if you're working in higher education, there's some real issues that you need to be aware of in terms of compliance and being able to store this data securely. And then there's also compensating controls. So for instance, if you're using a REST solution and you know that it doesn't support SSL, make sure you understand what it's going to take to be able to implement that behind your application's architecture. So in terms of securing NoSQL, the number one most important point is to understand your solution. You will absolutely have to read the manual. Just because there's no way for you to know otherwise what aspects of the security features that we've discussed today are actually implemented by the solution. And like I just mentioned, you must understand where your trusted operating environment exists. You also need to make sure that you don't throw out your defense in depth. It's been mentioned several times throughout this conference, but the defense in depth is really important with a NoSQL solution. These databases simply cannot operate on their own. And what's crazy is, if you go scan the internet, you will find people running these services on public IP addresses. And so if you go out there and you look, people are clearly not heeding the advice of these vendors. We also need to be aware of architecture creep. So we may need to add additional architecture to our solution in order to deploy it securely. whether that means adding an additional VPN or some sort of IPsec architecture, adding additional devices to load balance or support SSL. And we also need to identify these during development, not when it comes time to deploy these solutions, because it can radically alter the way that we work with the database. In terms of injection attacks, we need to make sure that we're always validating. So, like I mentioned, the attack surface for these databases is much more diverse than any of the SQL solutions that we've worked with. And we need to be aware of how these specific attack vectors can apply to our NoSQL deployment. So, we obviously need to continue to validate for our traditional attacks like SQL injection and cross-site scripting, but we also must be aware of NoSQL injection and things like server-side JavaScript injection attacks. And finally, we have to work with our vendors. So a lot of these projects are open source or freely available, and they have really quick release cycles. So if you are using one of these solutions in your environment and it doesn't have the features that you need to ask. Throughout the process of working on this presentation, I worked with a variety of NoSQL vendors, and they are aware of the shortcomings, and these are things that they are going to work on, but it will take time for these features to become available. So, several of the issues that we discussed today with authorization and authentication are on the roadmap, and they're things that we need to continue to watch for and continue to push for. Just like with SQL injection, it's not the job of the database to determine whether or not a query is valid. And with schema injection specifically, because we aren't constrained to specific rows or, specific columns, we can simply insert whatever we want to if it's able to get to the database. So if you're correctly escaping your input, anything that's within that password field would be escaped. And so you wouldn't be able to actually override that specific field. Now, if you're not escaping any of your input, then that's what permits us to actually do the override. Now, in terms of trying to whitelist these specific values, ideally the application would be adding that admin equals false at the very end. So after it's worked with all of the user's data. So even if they are able to potentially escape, then when this gets written to the database, the database will write admin equals true, and then see admin equals false later, and then be able to properly write that.
Yeah, I can have a conversation with you later because we're
Yeah.
a lot of this same spirit.
Sure. Okay, great. I think that a lot of the ways these specific solutions are being used in enterprises right now are in back office fashions, so they're not things that aren't necessarily exposed to the user yet. But I think that not being able to support things like rich authentication against like an Active Directory or using Kerberos is going to absolutely prevent a lot of these solutions from being adopted. Now, like I mentioned, Mongodb specifically is going to be rolling out Kerberos support very soon, which is going to be great. But right now, most of these solutions don't have that kind of support. So my biggest concern is with open source software specifically. A lot of these solutions are cool. Like we hear about them all the time. People are implementing shopping carts using these solutions. That's my big concern right now. Is credit card data, potentially sensitive information being stored in these kind of solutions, because while they're great, working with lots of data and solving very big problems, they don't have the feature maturity that we have with a lot of our relational solutions.
Can you speak about any issues with CQL?
CQL?
Yes.
I only looked at CQL a little bit, but I am aware that it is possible to do query injection in the CQL structure itself. So whether the schema and the JavaScript issues apply as well, I can't really speak to that, but there are definitely some issues there that you need to be aware of in the same way that you would try to mitigate a SQL injection vulnerability on a website. So if you can inject into the SQL query itself, you have the ability to modify the intent of that query.
So does it make sense to put a wrapper around it, to abstract between your application and this database, or is it something you're concerned that most people just won't bother to?
I think the way that the rapid deployment aspect of NoSQL has made this a bigger a bigger issue because many of these developers are solely focused on adding these great features for working with the data, and they're not focused on adding the security features at all. And now that they're trying to get out of startup mode and try to sell these products to enterprises, they're having to backtrack a little bit to add this kind of functionality. Now, in terms of adding a wrapper, absolutely. I mean, if you have a HTTP or a REST-based solution, for the most part, you're not going to have any SSL support, which means that if you are using authentication, everything is going to be passed over the clear. So you need to understand, within your operating environment, if that's acceptable. If you can ensure that no one has the ability to man the middle of that traffic, then that's great. But if that might be an issue, you would absolutely be looking at implementing a wrapper, whether it's a reverse proxy server or some other kind of solution.
I apologize. When I say wrapper, I didn't mean a TCP wrapper. I meant like an application wrapper where you have a front-end application that would really actually communicate back to this, rather than making this the forefront of your, actually this be the application. You actually have that as a back end to your application.
Right, yeah. And you would absolutely need to be implementing these kind of checks in that application itself. Now, my concern is, I'm sure you all have always heard the phrase, don't roll your own crypto. We don't want developers writing database authorization code or database authentication code. And so, since it's not supported, you're potentially putting, more responsibility on the developers to make sure that they're doing it correctly.
Any thoughts on Thrift as a protocol?
Sorry?
Any thoughts on Thrift as a protocol, Apache Thrift?
No.
As in, no, you don't like it, or
No thoughts. I haven't worked with Thrift specifically, so, but that's a good question. If you want to implement the additional architecture, and you can use a solution like that, then I think that's great. And right now, if you want to do something like add authentication or authorization to a lot of these databases, that's the only solution. Now, I do think that as they're adopted more, we will see these features start to pop up. But I think that's something that's going to come with maturity. Right. Yeah, you would have some sort of firewall rule where the database server can only be connected to by the trusted side of that wrapper. Right. But again, you're potentially looking at adding more architecture. That's definitely going to increase the cost of ownership for one of these kind of solutions. Okay, great. Well, I guess I can go ahead and let you all go, but if you all have any other questions, feel free to come up, or we can take it out in the hallway. Thanks for your time.